Imagine turning photographs into three-dimensional models, like magic. Instead of a flat image, you can view an object from all angles, rotate it, zoom in on details, and even three-dimensional print it. This is the power of three-dimensional photogrammetry, a technique that's becoming increasingly popular in various fields. From archaeologists documenting ancient artifacts to video game developers creating realistic environments, three-dimensional photogrammetry is changing how we capture and interact with the world around us. It's a process that seems complex, but with the right tools and understanding, anyone can create stunning three-dimensional models. This guide will walk you through the steps of three-dimensional photogrammetry, demystifying the process and empowering you to create your own three-dimensional masterpieces. Whether you're a hobbyist, a student, or a professional, this guide will equip you with the knowledge and skills to embark on your three-dimensional photogrammetry journey. Three-dimensional photogrammetry is the process of creating a three-dimensional model from a series of two-dimensional photographs. It's like piecing together a jigsaw puzzle, but instead of cardboard pieces, we use photographs to reconstruct an object's shape and texture. The key to photogrammetry lies in overlapping images. By capturing an object from various angles, we create a network of common points that the software uses to calculate the object's three-dimensional form. Imagine taking pictures of a statue from all sides: front, back, sides, top, and even underneath. Each photo captures a slightly different perspective of the statue, and the software analyzes these differences to determine the statue's exact shape in space. It's like triangulation, where multiple viewpoints help pinpoint a location. The more photos you take, the more detailed and accurate your three-dimensional model will be. You don't need expensive equipment to get started with three-dimensional photogrammetry. A basic digital camera, even the one on your smartphone, can be used to capture images. The key is to ensure your camera has a decent resolution and can capture sharp, well-lit photographs. For more advanced users, a DSLR camera with a macro lens can offer greater control over image quality and detail. However, remember that even a simple setup can yield impressive results. When it comes to software, there are several options available, both free and paid. Agisoft Metashape is a popular choice known for its powerful features and professional results. Meshroom is another excellent option, offering a free and open-source platform for three-dimensional photogrammetry. These software packages handle the complex calculations involved in turning photographs into three-dimensional models. They offer user-friendly interfaces and guided workflows, making the process accessible to beginners. Section 4. Capturing images. The success of your 3D model hinges on capturing high-quality photographs with sufficient overlap. Aim for a minimum of 60% overlap between images, meaning that each part of the object should be visible in at least 2 photos. Imagine you're photographing a vase. Start by taking a picture of the front, then slightly rotate the vase and take another picture, ensuring the front is still visible in the second image. Repeat this process, circling around the vase and capturing images from all angles. For smaller objects, a turntable can be helpful, allowing you to rotate the object while maintaining a consistent camera position. For larger objects, you'll need to move around the object, ensuring sufficient overlap in your photographs. Remember to maintain consistent lighting conditions throughout the photo shoot to avoid variations in shadows and color. Section 5. Processing images. Once you've captured your photographs, it's time to process them using your chosen software. The software will analyze your images, identify common points between them, and use this information to generate a 3D point cloud. This point cloud represents the object's shape in 3 dimensions, but it lacks the surface detail and texture of a true 3D model. The software will then use the information from the photographs to create a mesh, connecting the points in the point cloud to form a solid surface. Finally, the software will apply textures and colors from the original photographs to the mesh, creating a visually realistic 3D model. This process can take some time, depending on the number of images and the complexity of the object, but the results are well worth the wait. Section 6. Finalizing your model. After processing, your 3D model might require some final touches. You can use the software to clean up any imperfections, remove unwanted artifacts, or smooth out rough edges. Some software packages allow you to fill in any gaps in the model, ensuring a complete and seamless representation of the object. You can also scale and rotate your model, adjust its lighting and materials, and even export it in various formats for use in other applications. For example, you can export your model as an OBJ file for 3D printing, or as an FBX file for use in video games or animation software. The possibilities are endless, and the final touches you apply will depend on your intended use for the 3D model. Section 7. Conclusion. 3D photogrammetry is a powerful technique that allows you to transform ordinary photographs into extraordinary three-dimensional models. With readily available tools and a bit of practice, anyone can create stunning 3D models of objects, both large and small. From preserving historical artifacts to designing innovative products, 3D photogrammetry is opening new doors in various fields. This guide has provided you with a foundational understanding of the process, empowering you to embark on your own 3D photogrammetry adventures. So grab your camera, explore the world around you, and unlock the magic of turning photographs into three-dimensional masterpieces.